So regarding the Bertrand's paradox video, the first one, I made that immediately after learning about Bertrand's paradox. So that is literally me just demonstrating my thought process in real time. Everybody's like, I don't know, I don't think you know what you're doing. Blah, blah, blah. Or there's like it's a paradox. You don't get it. Or like they'll pick one of the wrong ones and be like, but you're not promoting the wrong one. You're not promoting this one. This is the one that I like best. Okay, so the problem is, what does random chord mean? Okay, I've done a follow-up video, and I've done lots of comments where I was working out my ideas in both videos. So if you're too lazy to go read the comments, which there aren't that many because not many people watch my shit, and you're too lazy to go look at the other video, well, you're an idiot. Fuck you. Okay. Since you're watching this one, I'll presume that that is not you. Okay? So, I wasn't flipping you off. Anyway, okay, so I've demonstrated now there's 4 possibilities. There's possibly more. So one of them is we pick 2 random spots on the perimeter of the circle and we connect them, right? Intuitively, this is what a chord is. But really what this is finding is it's finding a random arc on the circle, not a random chord. And the distribution here is a little bit off. If you really look at it closely, you end up with kind of a weaker, an emptier center in the circle than you get around the perimeter. It's not as prominent as with another method, but it is occurring, right? You get a bias towards chords that are closer to the perimeter than you do going through the center. So that's not really a random chord. Also, the length is now determined by the properties of the circle, right? So the length of the chord is not random. So there's that. The position of the chord is not random. So there's that. All that happens is the ends of the chord is random because what we're doing is we're choosing an arc of random length with a random position around the circle. Okay, so that one, I don't think that when you really analyze it, you're not looking at random chords. You're looking at random arcs. And that produces sort of a random chord in response, but it's not fully random, I would say. And you're free to disagree, but I'm making my case here, so. All right. Now, another method was to look at both of the triangle and the circle together. And when you do that, you get a 1/2. Well, so with the first one, you get the long arc, the long chord occurs 1/3 of the time, because 2/3 of the time your arc is shorter. So say we're starting at one of the vertices of the triangle, your arc is going to be 2/3 of the time it's going to be so short that it can't reach past another vertex of the triangle. So 2/3 of the time you get a short chord, and 1/3 of the time you get a long chord. If we're looking properly at the circle and the triangle, and we're just placing lines, and then it becomes a chord because we're cutting it off where it touches the perimeter, we get long chords half of the time, and we get short chords half of the time. And this is because of the way that you actually make the triangle inside the circle. The properties of both the circle and the triangle yield this. There's another one where we're looking for where does the midpoint of a chord land. And now a long chord, the midpoint fills 1/4 of the area of the total circle, the central quarter. But that doesn't really mean anything because all of those chords also have to pass through the other part of the circle somewhere. So why are we interested in the midpoint? And notably, when you run this experiment, what happens is you get sort of an empty patch in the center. Right? So it's not random chords here. And then there's another one that I demonstrated where you get a probability of 1 minus the square root of 3 divided by 2 to 1 for a long chord. And the short chord occurs root 3 on 2 amount of the time. And what I did here is I'm just looking at the diameter of the circle related to the length of a side length on the triangle, right? So you just use that straight up as your ratio. Now, this one isn't going to be random in my opinion. It's not a random chord because what we're doing is we're picking random lengths, but that very strongly biases chords that stick around the perimeter. Right, so you're going to get a pocket in the center. So with the 1/3 method, which is a random arc, you get a pocket in the center. With the 1/4 method, which is where we're looking at the midpoints, you get a pocket in the center. And with the root 3 on 2 method, you get, which is we're comparing the lengths, the diameter of the circle to a side length of our triangle. You get a pocket in the center. These all have a problem because how can you say that you have a random chord now? Because the position of the chord is not random. It is determined by other factors. You're randomizing something else, and the chord kind of comes along for the ride, but the chord itself is not what's randomized. If we randomize the properties of the chord, where it's located, and its orientation, which turns out not to matter because it's a circle. So, like, if we properly randomize, like, say, where its midpoint is, and its orientation, we're going to get the 1/2 method. That's what's going to happen. And the, that invariance thing where so you just drop a whole bunch of random lines in a space, and then you take circles of, you can choose the size and you can move it, and you're going to get the same ratios. That's the 1/2 method because it's correct, right? It's not the other way around. Like what they were saying in the number file video is that the argument that whatever is, I don't care, I don't remember. The argument that the guy was making was that the 1/2 method is correct because of this invariance, this translation invariance, I think. No, the translation invariance works because it's correct. And we can see that it's correct because when we truly try to randomize the chord, that's what we get. When we randomize the arc, we get the 1/3 method. When we randomize the location of the midpoint, well, when we treat the relative area of where the midpoint lands as our randomizing factor for locating the midpoint, that's when we get the 1/4, and that was really fucked up. When we randomize the length of the chord, we get 1 minus root 3 on 2 for a long one. And when we actually just randomize the location of a chord, which is kind of the only one that's really randomizing a chord, maybe the length one, we get the 1/2. So personally, I favor the 1/2. I think it's the only real answer. And the other ones, you can say it's not a random chord because we're randomizing something else, right? So if you randomize, the reason I don't like the randomized length of the chord is because all you're doing, you're picking your length from 0 to 1, and then you have to then figure out where it sits. You have to figure out its orientation. Okay. But fundamentally what a chord is it's a line segment, which is, it's a vector. And a vector has two basic properties. It has a location and a direction. So when we pick a location and a direction randomly, that gives us the 1/2. No other thing gives you random location and direction. No other thing randomizes that vector. Everything else sort of it gives you a skewed distribution. Right. So usually it ends up favoring the perimeter of the circle somehow. All of the other three methods favor the perimeter of the circle because we're not properly randomizing qualities of the chord. You feel free to disagree, but I think that's the most reasonable way to look at that. And if you're going to try to come in now and say that I don't understand what I'm saying, you're wrong. I do understand what I'm saying. You don't understand what I'm saying. And this is what I said within 24 hours, this was what I was saying, right? Within 24 hours of me even hearing about Bertrand's paradox, this is what I was saying. Okay? And now, note that this has been a paradox for mathematicians for over a century. So, fuck you. It's not that hard. I worked this much out in a day. It's not that complicated. What you're doing is you're either savoring the fact that it's a paradox and throwing away any resolution to it, or you're looking at it wrong. That's it. That's all there is to it. So, yeah, I mean, if you want to keep leaving stupid comments that I don't know what I'm talking about, okay, but I'm not going to read them because I don't give a shit. You're wrong as far as I'm concerned.